Right, we are on the path to find surface area this time, surface area of 3D objects. Now we're moving off the page into real life shapes, and we're going to start looking at some 3D ones. For example, this cube. Alright, here is my cube. I have stolen it from my cupboard. It's just made out of cardboard, and what we're trying to do if we're trying to find surface area is figure out exactly how much cardboard is used in order to create this shape. The only way we can really figure that out is, well, a nice simple way, sorry, is if we actually unfold it. So I'm going to unfold it, and I want you to see exactly how many faces this 3D shape has. So I've unfolded it, and we can see there's 1, 2, 3, 4, 5, 6 different faces. However, if we look really carefully, they're all the same. Okay, the special part about a cube or a 3D object there is that all the faces are the same shape. So if I had to draw a cube in a 3D way, it'd look something like that. Not great, but you get the idea. But if you wanted to draw its 2D net, we would have to draw an awful lot of squares. All right, if each face of this 3D shape is a square, then when we unfold it, we will see 6 squares exactly like we have just here. So this is called a 2D net of a 3D object. Right, this is of course our cube. Our next one is going to be our rectangular prism. A really common shape, and again, went to my cupboard, found another rectangular prism, and here it is. Okay, box of tomato paste, and I put it back together again for you. I'm going to unfold it so we can see what it looks like on the inside. Alright, so here is the unfolded rectangular prism to look at, and if we have another count, let's go, we've got 1, 2, 3, 4, 5, 6 faces once again. But you can see that the faces are a bit different this time. This time, instead of a square, we have rectangles. All right, this is why it's a rectangular prism, because it doesn't matter where you would cut. If you cut straight down, you would get a rectangle. The important part is that you look, that like the front and the back of the box are the same rectangle. The sides of the box are the same type of rectangle, and the top and bottom of the box are the same type of rectangle. All right, so if I flip it over, here's the front and back, the 2 sides, and the top and bottom. So we have 6 rectangles, but we have pairs. They're in pairs. So 2 and 4 are the same, 1 and 3 are the same, and here 5 and 6 are the same. So if I had to draw the 3D shape, if I was laying it down on its side, it would look a bit like that. And if I had to draw our 2D net, we would have a side, the front, and not great, another side, sorry, the back of the box, and our 2 lid and bottom rectangles. So this should be the same as this one, 1 and 1, 2 and 2, and 3 and 3. Not very neat, but you get the idea. Right, our final shape here is going to be a cylinder. And here's my cylinder. Stole it again from a cupboard. Big can of baked beans. Easy to understand, easy to picture. But I want you to see that on the outside we have one big circle. On the flip side of it we have another big circle. And we've got this kind of long shape that rolls around the outside. Now, baked beans are perfect for this because what I can do is I can unroll this and show you what the shape is. Nice and easily, the shape's just a big rectangle. And the rectangle rolls all the way around the big circle. Okay, so the important point, if we were to draw this in a 3D way, so this is how we would usually draw a cylinder, something like that. But when we draw a 2D net, the important part is to get all the shapes. So the top of our can is a circle, and we know we've got the bottom of a can is a circle. And remember, that label that fits all in between, that is just a big rectangle. So that is our 2D net. It's got one face that's the same as the other, so our circles are the same, and then it's got the outer ring, or the label part of the can. So again, this is our 3D, and this is our 2D net. And there are shapes we're going to work with for surface area.